Test benches are generally used to generate stimuli in your design during the simulation and check the output values of your design. The vhdl component is connected in a simulation environment that provides the input stimuli, for example using a behavioral vhdl code, a process that reads from file, a vhdl RTL or behavioral component that provides the input to your DUT, device under test. The output can be simply evaluated on a simulator wave window or dumped on a file, and or verified versus a reference value or a reference design, generating an error signal that simplifies the output evaluation. For example, if the DUT is your post layout netlist, coming from the layout tool of an FPGA or ASIC, the reference design can be simply the RTL netlist. This strategy allows you to verify clock by clock the output of your DUT netlist, checking the result in a simple way. Let's see how to write a test bench. Suppose we want to test an adder. An adder is a simple circuit with clock and reset, enable and the two operand, and the valid and the output of the adder. In this case, enable is passed on valid and the output is the sum as signed of the two operand. We want to read from file the stimuli operand 1 and 2 and check the output, also reading from file the result. The file is something like that. 3 column, input operand 1, 2, and the output. So let's see how to generate something like that. We have a test bench where we pass the file name, this one, and we have the component header, the signal, an error signal, and the clock generator and reset generator, a simple process used to control the input enable, simply generating a counter using a variable and checking the last 4 bits of this counter. When the old bit are 1, enable is 1. Else enable and the counter is greater than 0. So we have the other instantiation and a load process. The load process is used to read from file the first 2 columns. In order to simplify and making a template of a read file, we use a number of columns of an integer array, the file open in read mode, the type integer of data, and a variable that we can use as a counter, a line counter. And the reset, all the bits are 0. Then, if the enable signal is 1, we read from file the operand. Before reading from file, we have to read all the columns into the array and then select the array. For the matching process is very similar, and every time the output is valid, we read from file and select the third column. Then perform the matching between the output of the other and the value read from file. Okay, let's simulate how we can simulate this using this script where we compile other, the test bench 1, and pass the name of file to the generic using -g name of generic and generic value, and recall the wave read write file .do script, the script of the wave Okay, so start model sim, select the current folder, let's copy, change directory, okay, create work, and run the script. Undock the wave and run for 3 microseconds. The error is because we reached the end of file. In this case, the error is this red triangle. You can see that the error signal is yellow because we changed the color. To change the color, double click on signal and select the color. Okay, as you can see, the error signal is 1, but the other value is correct. Why? Let's zoom in so you can guess why. Do you guess why? Stop the video and try to answer. Well, the solution is very trivial. You can see that the enable signal is 1 clock cycle before the value of the operand. So we need to add a clock delay on the enable signal. In fact, the output value is 1 clock cycle before the output. In other words, we need another control signal, enable load, driven from the control process, and we have to drive the enable signal in the same process that drives the operand. So when enable load is 1, enable signal is 1, else is 0, and then the process is the same. Let's try to simulate. Microsecond, and in this case the error signal is 0. In fact, we have enable load, the input operand with the correct timing on the enable signal and the correct timing on the valid signal. This is the matching data read, the third column. You have to check, remember that this is a variable and this is a signal, so you just perform the check here. In this case, the output error is 0.